And just a little intro to John's talk. He's going to talk about SonarQube, which is a source code analyzer, and he found some pretty cool ways to use the API that they probably didn't intend to be used. So he's going to, give you some pretty cool information there on how you can do remote code execution or even have backdoor access just using the API and no other tools. So let me bring John in now.
Here, everybody hear me out?
Sound check, John?
Sound check, can you hear me?
Yes. Yep.
All right, well, thanks for having me. My name is John Williams. I'm going to be giving a talk today on what you can't see can hurt you. This is how to use the SonarQube API to do privilege escalation. Let me get my screen up here. All right. So a quick agenda for today. First of all, I'll do a quick intro of myself and our target, which is SonarQube. He'll move on to some reconnaissance, how to identify exposed instances of SonarQube and gather information from them. After that is weaponization, how to actually get a foothold within exposed instances of the application and prepare the exploit, which is the focus of this talk, which is how to escalate privilege from the application front end into the backend server. The last part, of course, exploitation, how to kick off that exploit. And then at the end, we'll talk about how to remediate this vulnerability. So a little bit about me to begin with. My name is John Williams. This picture here is actually from Election Day because this is how 2020 has been going. I do have a few certs to my name, both from the blue team side and the red team side. I started out my career in IT in a support role for a financial software company. And over the time I was with them, I grew up into systems engineering. From there, I got interested in security. I took on a role at a SOC in the financial sector and spent my time there learning about digital forensics and incident response. Then made a jump over to the red team. And at the moment, I am working as a penetration tester for Bishop Fox and greatly enjoying my time over there. I just want to do a quick level set about the talk. If you're here looking for a hardcore technical code exploit, then I'm afraid this isn't going to be the talk for you. But my focus is on simplicity and creativity. I'm going to be talking more about how to find features in an application that are intended, but then abusing them for means that weren't intended. The reason I'm doing this is in offensive security, I find a lot of attention gets given to incredibly smart hacks, and rightfully so. I mean, there's some brilliant people out there, some brilliant ideas that they come up with of how to dig deep into code and find exploits that are really technical. And that is awesome, and it's well-deserved. But in my experience, in offensive security, the bulk of the day-to-day work depends a lot less on these complicated attacks and much more on creative thinking. And it can be intimidating when you're first starting out in the field because the people who are held up highest are the ones who are really deep in the code. But the fact is, if you are able to analyze your attack surface creatively and abuse what you find there, you can get really far just doing that. And so my goal here today is just to demonstrate how to use an attacker's mindset to compromise a target. So what is our target? It's SonarQube. This is an application that is open source, used mainly by developers, and it's pretty prevalent across the internet today. It basically has several different functions. It acts as a code repository, so you can store code, collaborate, and work between developers. You can share permissions. You have pretty granular permissions to how you access different projects within it. It is a static analyzer, which means you can use it to run scans of your code to identify common coding errors and bugs in your software. And it's designed specifically to integrate with continuous integration and delivery pipelines. So it's great if you're a DevOps shop. And lastly, it does security audits. So in addition to looking for bad coding, it can find actual vulnerabilities and other oversights within your code that could be exploited. Overall, pretty great tool. This is a picture of their website, super snazzy. And from what I've seen, SonarQube has a pretty high adoption rate among developers. I regularly encounter this platform while I'm testing clients of ours. And so that's what made me choose it as a target for this talk today. It's pretty relevant. Unfortunately, SonarQube has had a little bit of bad press recently. The FBI has been warning that hackers have been actively targeting exposed source code in SonarQube, specifically in US government agencies and businesses since about April. But I do want to point out, this isn't really much of a slight against SonarQube itself, because they're not emphasizing that the software is vulnerable. More often, it's hackers taking advantage of misconfigured SonarQube instances. There do tend to be a lot of exposures, and we'll get into that in just a minute. So that brings us to part 2, reconnaissance. So if we're looking for SonarQube and we want to find exposures online, how are we going to do that? So we'll start with the usual suspects for open source intelligence. Shodan, Census, Binary Edge, and other mass scanning tools out there are great for finding this. And that's because the default port for the administration console is 9000. So if you're using these tools, all you got to do is search for exposed 9000, and you'll find a lot of SonarQube that way. Also, Google, if you target your search correctly, you'll find a lot. And all you got to do is look for the login page, which is at sessions new. And the title will have SonarQube right in it, so you can get hits really easily just searching on Google for this. I did do a little bit of this to prepare for my talk today, just to be able to throw some images up. So this is Binary Edge doing a search for port 9000, and it gave me a lot of good hits. This one, for example, on the screen, you can see it looks very promising. It's got port 9000 exposed. The title of the page is SonarQube, and it's returning HTML body content. So all of those things are good signs. This is one you'd want to look closely at. It probably has some exposure. Now, once you actually browse to the site, it's a toss-up, as to whether or not it'll actually expose anything. But for example, this one, I came across this within about 5 minutes of doing my search to prepare this presentation. You'll notice I'm not logged in. If you look at the top right corner, the login button is there. And yet we have several projects showing on the screen, each of those containing source code and other things that you can dig through. And this is all publicly accessible, right? So what is the danger of having exposure like this? Because we're talking about source code, if this is, especially if you're a company and not just an open source developer, just writing your own code, but if this is commercial software that's being exposed, you're giving away the software stacks that your software relies upon. So all the dependencies and what platforms it runs on. You may be giving away server locations if your software interacts with other services. Now those web addresses are exposed, and we know how to interface with them directly. File paths, you could find sensitive files within the code itself, that wouldn't normally be accessible through the application, or if it's interacting with an online service, you could find paths to sensitive information within those services. They might expose proprietary data. Again, if there are files you're not supposed to be able to get to through the app, but they're disclosed in source, that could be really bad. In some case, you could actually get a company's secret sauce, right? If their whole business model depends on a particular proprietary algorithm, and that's in the code that they've inadvertently left exposed online, that could be a really big problem for them. Not to mention things like credentials, keys, tokens, and other secrets, which you can use to, either get into the application itself with privileged access, or to other sites and services that it depends on. Or just sometimes it's even unrelated services. You might find random credentials strewn about your source code, just like in GitHub. And not to mention bugs and other security vulnerabilities, because after all, SonarQube is a static analyzer, and so the results that it finds in its scans could also be exposed and give you a leg up on how to attack the code. All of this basically, amounts to a treasure trove of information for an attacker. So it's definitely something that they've been looking for, as we've seen. So now, once you find some instances of SonarQube online that are exposed and they have projects showing, how do you actually find interesting or valuable data within them? And there are a few different ways you can approach this. The hard way, of course, is just to manually browse through the source code. And that's great for getting your bearings, understanding what an application is, how it works. And this is great for small projects in particular, where there's not a ton of code to go through. But if you are doing a much wider survey, or if you find projects that are much bigger, this becomes impractical. Much easier is to use the issues section within SonarQube. Here is where you have the results of your scans, all the things that it's found when looking at the code. And they make it real easy to filter by category. So you just go down the left, find the categories that you're most interested in, and then see what comes up. As an attacker, this is great because you can focus on the security categories and hone in on exposed credentials, on suspicious comments, on like potential SQL injections. All kinds of things will come up here. You don't even have to do the work because it's already identified it for you. Then, of course, there's this. In more recent versions, they've added a feature called security hotspots. And for an attacker, you click that, it takes you straight to the goods, just like this hard-coded credential that I found. And yeah, this is exposed online. If you're paying attention, the name of this application is EMS. That stands for Election Management System. I found this exposure within minutes of preparing this presentation, and I am not going to bother obfuscating it because anybody can find this. This is the state of our election security in 2020. Now, automation is also great for these kinds of exposures, right? SonarQube has an API that makes it really easy to retrieve all the code from a project. So if you find one that's exposed, you can write a simple script to query the API and pull all the code down. Once you have the code offline, there are tons of open source tools online that can help you dig through that data and hunt for secrets. Dumpster Diver is one of them. I highly recommend it. It's a great tool for this type of thing. There are also plenty of others out there you can choose from. All right, that brings us to part 3, weaponization. So exposed code is one thing, but what about actually compromising the SonarQube platform itself? And this is where it starts to get interesting. You know, we want to actually get access to the administrative console within SonarQube. So how do we do that? There are 3 main ways. One, we've already talked about a little bit, through credential exposure. And anywhere that there's public code, you might find credentials that can get you into the application. You might actually find a SonarQube repository that has public-facing code with the credentials to get into SonarQube itself. It would be stupid, but it could happen, right? Also, GitHub, GitLab, you know, the last talk focused a lot about hunting for vulnerabilities in GitHub. If you're looking for credentials, you could find things that'll get you into SonarQube, as well as credential reuse, right? There are always breaches there and leaks and other ways of credentials coming out. Password spraying, you can take those credentials and find like different services they will get you into. So all of those, you know, are an easy way to get into SonarQube initially. The second approach is to look for vulnerabilities in the application itself. Now, in my experience, overall, SonarQube is actually really good on this front. There aren't very many vulnerabilities. There haven't been many in its history. And when they have come up, they've been pretty transparent about dealing with them and resolving them in a good way. But that said, you can still find older versions that are publicly accessible that have vulnerabilities, like this one. In some cases, if there's a Jenkins plugin installed, you can abuse that to disclose the credentials and then log into SonarQube itself. So that's another way you can get in. The last way, of course, is just pure stupidity. And this is the most common way, right? When you first set up SonarQube, it has default account credentials, admin. So you'd be shocked at the number of times that SonarQube gets stood up, left exposed to the public, and this account is never changed. It really is that simple sometimes. And this is what the FBI was warning everybody about. You know, just lock down your software. Don't make it open to the public. And yes, that election site that we were just looking at also had this problem. They hadn't changed the password on their admin account. All right, so once you are able to use one of those 3 approaches and get a foothold within the server, now you have admin access. So from here, what can you see? So let's do some enumeration. Within the admin console, there's a configuration section. and you can review the configuration for a variety of different integrations. So you can see the mail settings, you can see code version control, you can see single sign-on. If they've configured to store their code externally with GitHub or GitLab, then that config is there. And they also have webhooks for interfacing with SonarQube programmatically. None of those passwords are disclosed within the UI, which is great. That's really good on SonarQube's part. But all of the other configs are there. Security, that section allows you to control your users. And particularly with some corporate sites, once you get to this point, you can start understanding who their developers are, who their administrators are. You can capture emails, sometimes a lot of emails, depending on how many people they have in their system. You can see what groups they belong to, what projects they have access to, and start to understand who's responsible for what. And of course, you can manipulate all of these things. Projects. In SonarQube, projects can be public or private, and as an administrator, of course, you have access to all the private projects as well. So that's, just like we were talking about before, there's a lot more code that you can go through and check for, things that might be exploitable. In addition to the code itself, you have the issues section, so you can review scan results, and reports, which collates the results of all of those scans. Now, before I move on here, I do want to notice, give a shout out to Christian Gutierrez. Pretty recently, in October, he released some research showing that there is an API endpoint at API settings values that actually discloses the passwords for some of those integrations we just talked about in clear text. So the mail password, GitHub, GitLab secrets, and possibly some others can be disclosed through the API, and that was a really great find. In that particular instance, I don't think you even need administrative access. Depending on how things are configured, you might be able to get in and get that information with a low-level account or even without any access at all. So that could, if you find something that is exposed that badly, you might even get a credential that lets you log into SonarQube just by going to the API. But I wanted to give credit for that finding. The other thing that having admin access gives you access to is the system section. And here's where all the juicy features are, right? You got the server ID and version. You have the path to where SonarQube is installed on the server. You have database connection details. As far as I'm aware, the password for database connections is not exposed either in the UI or the API. But maybe somebody will figure out a way later. The Java virtual machine that runs SonarQube, all of its configuration details are accessible here, as well as the version of Java that it's running on. And then you have these handy buttons at the very top of the screen. You can just download all of the logs that SonarQube produces, and you can download all the system info. So if you just want to hop in and hop out real quick and then review all of that data offline, you can do that. So there's, again, a wealth of information available to you as an attacker here. And of course, then there's a restart server button. So you can very quickly reboot the SonarQube application just by clicking that. So what does all this amount to now? What's the potential impact? And as an attacker, what damage can you cause through this web UI? So you can mess with all of those config settings that we just went over. So if you want to break their mail integration or cause some havoc, you can do that. You can add users, you can remove users, you can put in a backdoor account for yourself, you can boot out the admins. Like it just depends on what you want to do, but all those user settings you can manipulate. The projects themselves you can manipulate, and here's this, depending on how they're using SonarQube in their company, this could be more or less dangerous. If they've integrated their projects into some kind of CI/CD pipeline, any small change that you make within the code then just gets funneled down through the pipeline and possibly could make it all the way to distribution. So you could either break somebody's app, break their distribution, or you could plant something malicious in it and basically, cause a supply chain attack. You can change the logging level. So if you want to get a lot more detail from SonarQube about the scans that it's running, you can do that and then download the logs. Mentioned already, you can restart it. There's also a plugin installation feature. However, it's a little bit limited in scope because you can only install plugins from the marketplace, which is curated. But in general, there's a lot of mischief that you can cause just with access to the administration dashboard, right? Now, what about the API, right? So far, we've only talked about what's accessible through the front end. But if you go down to the bottom of the page once you're logged in, there's this web API link. Click on that, and that takes you to the documentation. And this is brilliant. As an attacker, again, it's like, oh, this opens up everything now. You can see the commands that are used to do all the functionality within the front end. And if you notice up here, they give us a couple very handy little toggles to show some additional API commands, internal and deprecated. Let's take a closer look at that. If we turn on the internal API endpoints, they point out to us as a caveat that these endpoints are subject to change without notice, so fair enough. One of the ones that comes up is called Update Center. When we take a look at this a little closer, we find out that here we have a command that will allow us to upload plugins to the system remotely, as long as we have administrative privilege. Excellent. So now we have what we need to formulate a plan of attack. So here's what we're going to do. Step one, we're going to write a malicious plugin. Step two, we're going to use the API to upload it into SonarQube. Step three, we're going to restart the app server so that it loads the vulnerable or the malicious plugin. And in so doing, we'll compromise the target. Sweet. So let's get started. But in order to do this, we got to know where to begin, right? Like, how do we even build a custom plugin? What does that look like? Fortunately, SonarSource, which is the company that makes SonarQube, is really helpful in this regard. They have great documentation online, including an article about how to build your own custom plugin. And they go the extra mile. They actually give you a GitHub repository with a sample plugin to show you how it works. So awesome. Now, I spent a fair amount of time going through this documentation, trying to figure out how this works and how to exploit it. And I've distilled it down into a few main takeaways, right? So the things that you need to know in order to build your own plugin are SonarQube and the plugins are written in Java 8. They follow Maven project structure, so you can build the plugins with Maven. And for testing, you can use Docker. Because SonarQube is open source, they've been great about making containers for each version that they've released. So it's super easy to set up a test environment for development. So if you're going to build your own malicious plugin, first step is just to install these prerequisites. Now, let's have a look at what the plugins actually look like, right? What I did here is I took the example plugin that was available from SonarSource, made a copy, analyzed it, figured out how it worked, and then I just kind of, trimmed it down to the bare minimum. So this is like a minimum viable plugin, if you will, for this exploit. And when it comes down to it, there are only actually two files you need, plus a little bit of scaffolding. First file is the POM files, the project object model. This is standard for any Maven project. It's just a file an XML file that has some metadata in it that defines the project structure, as well as the name of the plugin, etc. The other file is the Java class, and this actually contains the code that will be executed when the plugin runs. And that's it. So let's have a look at those two files now. This is the POM file, and the whole file is bigger than I could fit on the screen. So all I did was took out the parts that you need to change from the example plugin that they give you. And there's only a few fields, right? And they're pretty arbitrary. You can call the plugin whatever you want, write whatever description you want for it. There are really only two values here that are tied to the project structure. So the group ID and the plugin class, those ones have to correspond to part of your project structure. So if you remember the other file that we have, I named benign.java. If you were to change the name of that to something else, then you would also have to change that name in the group ID and the plugin class. So just be aware of that if you play around with this. So now, looking at the Java file itself, I apologize for the small text in this case, but this is the entire file. At the top, you can see that we have a bunch of import statements. And so I forgot to mention, our goal here is to make a plugin that is going to execute a reverse shell, right? So they load the plugin, it makes a callback to a server that you control, and pop a shell on the back-end server of the SonarQube installation. So in order to do that, we need to import some Java libraries that will support networking. So we've got those at the top. And then for SonarQube to recognize this as a plugin and know how to interface it, we have to import a couple of their libraries. So that's what the Sonar libraries are that we're importing. Under that, you have the class itself. And the class name here is benign. And that corresponds to the name of the Java file. So again, if you change the file name, change your class name here. Within the class, we have two functions defined. There's the main one, and then one called revshell. The main function is very simple. All it does is it sets up two variables that define where your listening host is. So this is the only thing that you have to change in order to use this plugin the way that I've written it. You specify your attack host, either IP or host name, and the port where you want to receive your callback. Then the function takes those two things and it calls revshell with them. The revshell function it's very simple. It uses a bash one-liner to open up a reverse shell back to the target that you specified. Now what this means is that this will only work against Linux hosts. And I wrote it that way because all the targets that I've come across for SonarQube are Linux. However, you can run it on Windows. There are some Windows hosts out there. So if you were targeting them, you would need to change the way this function works. Now, I'm not a Java developer, and I'm sure that there's a way that you could implement a reverse shell in native Java code, and then it would be cross-compatible. So I'll leave that as an exercise to the readers, to try and figure that out later on. But for now, we're targeting Linux. So once you've got your code all set, it's time to build it. And fortunately, this is super simple. All you got to do is open a terminal, move into the directory where your plugin is, and run maven clean package. Boom. If you're using the code that I provided here, it's really quick. Of course, if you modify it, then you might have to do some troubleshooting, but as soon as it builds cleanly, it will output a jar file into the target directory. And that's it. Now you have your exploit. So all that leaves is the exploitation. Now you may be tempted at this point to just take that jar file and fire it at your target server and see how it goes. But be advised, if the plugin fails, it could crash the SonarQube server. And if you do that, then you're out of luck, right? You've lost your foothold. You can no longer get in and restart the application. Like you're done now. So testing is highly recommended. And because there are Docker containers available, that part is actually really easy. All you got to do once you have Docker installed is to use this run command to pull down a container and just test it out locally. Make sure you use a version prior to 7.9.5 if you want to exploit this API endpoint, and make sure you expose port 9000. So once you spin that up, then all you have to do is browse, pull up a web browser and go to localhost port 9000, and you can log in with the default credentials admin. Remember now, if you are testing a reverse shell, you'll want to make sure that your listening host is using a publicly accessible IP. Otherwise, you'll have to do some networking configuration because by default, your Docker container can't talk to the host environment that it's running in. So you'd have to build networking in to allow that to happen. It's much easier just to stand up like a listening host in AWS or something and have your container call out to that IP. When you're all done with your testing, just tear it down using docker stop SonarQube, assuming that you use this name command when you fired it up, then it becomes really easy to tear down. All right, after you're done testing, we're ready to exploit. So first step is to fire up a netcat listener, then open up a second terminal, and you can use curl to send the plugin to the vulnerable API endpoint. All you need to do is use the user flag with the username and password to log into the SonarQube instance, set the method to post, use the use the form post flag to make sure that you're uploading the file with this file label to make sure that it gets there. And the @ in front of this will make sure that it actually uploads the jar file instead of just sending the name of the file. Then the URL, of course, is where your target is. You may need port 9000 on that. You may not, depending on which one you found. And then the path is API update center upload. Assuming that that goes through without an error, then the plugin has been uploaded to SonarQube. And then the last step is just to restart. You can do that with another curl command. You just submit an empty post request to the path API system restart. Give it a few minutes. It will take a few to go through the restart process within the application. And it's at the end of that process that it loads the plugins. But as soon as that plugin gets loaded, boom, you should get your call back. And most likely, when you get that shell, you'll be in the context of the SonarQube user, but you might get lucky. You might have more privilege than that, depending on how the application was configured. I'm pretty sure in Windows environment, it's more common for SonarQube to run under the system account. So there you go. Now, if it went off smoothly, your plugin got loaded into the dashboard and you just successfully escalated from an application administrator to a user on the backend server. And from there, of course, the next step, you can conduct local reconnaissance, you can download sensitive files off the server, and you can look for other opportunities to elevate your privilege, or maybe even look around the internal network and pivot to other hosts. A few other things to consider, though. If you missed your callback or if you end up losing your shell at some point, it's really easy to get it back. All you got to do is restart the application again. And if you're feeling a little lazy with the command line, you can always just log into the dashboard and then click that restart button to do that. That'll get your shell back real quick. If you loaded a plugin, but for some reason it didn't work, especially if you modified it, from the one I'm providing here, you can always uninstall it through the dashboard. They make it really simple to just select the plugin and then remove it. Then you restart the app again. And of course, when you're done, make sure you clean up after yourself, right? Whether you're testing or whatever, it's just bad form to leave your back door after you're done. So last but not least, what if you're on the other team and you just want to know how to defend against this attack? Turns out it's really simple. All you got to do is upgrade to the latest version of SonarQube. So starting with version 7.9.5, the Update Center API endpoint doesn't allow you to upload custom code anymore. It only lists the installed plugins. So that's good. SonarSource was actually really gracious when I reported this issue to them. They informed me that they'd already dropped it from their current version 8, but they acknowledged it was still an issue with their long-term support version 7. They did get on top of that and they remediated it. So at this point in time, the current version of both 8 and long-term support 7 are not vulnerable. So as long as you upgrade to the most recent version, you won't have to worry about this particular attack vector. But if you're an administrator, keep in mind, an attacker can still abuse the plugins to plant a backdoor. They would just have to find some other way to get in the server first. So if there was some other vulnerability, they could still use SonarQube to give them a backdoor account. Also, make sure that none of your projects are publicly exposed. Like we talked about before, you can set them private, public. Make sure you go through all of them and mark them as private. And the easiest way to do this is if you go in your administration panel under configuration and security, there's an option you can just toggle to force user authentication. And if you do this, your public projects won't be publicly accessible. The API commands that could potentially disclose things won't be accessible without authentication. So this is a really good way to just lock it down. Then, of course, you want to change the administrative account password. Don't forget that. Don't leave admin open. And realistically, like if you're in a corporate environment, you should have this whole platform behind the firewall. It shouldn't really be on the public internet anyways. But if you are going to expose it, you can do these things to lock it down. And that's all I got. If you're interested in playing around with this plugin yourself, you'll find it on my GitHub page, along with instructions for how to, modify and build it. I will also put a copy of this slide deck up there if you want to review. So thanks a lot for having me. It looks like I'm actually just a little bit over time, so I won't be taking questions. But if you want to chat with me, I will be hanging out in the Discord channel. So thanks a lot.
John, thank you very much. That was a great talk.
Thank you. Appreciate being here.
Yeah, awesome. Yeah, everyone, John will be in the Discord. Hit him up.